So, good afternoon guys, welcome to NEET World Institute and NEET World YouTube channel, and in this class we are going to start with our electric charges and fields of the EAPCET marathon, right. So, as we have completed the class 11th chapters and practicing questions, right, we are moving forward with the class 12th, right. So, let we start from the introduction point of view. Electrostatic. So, electrostatic, which like we'll go with the overview of this. Okay, electrostatic deals with the study of force, field and potential arising from static charges. What is the meaning of static charges? Static charges is nothing but like the meaning of static is nothing but rest, right. So, the rest charge we are talking, right. So, this is null like extra points, like points which we need, we will see that one, and when we will go for the things. Okay, that is the meaning of electrostatic. Okay, electro is nothing but like charge particle, and static is nothing but the rest. And the next one is a conductor and the insulator. So, substance which allow electricity to pass through them easily are called as conductor, and examples are like metals, human and animal bodies and earths. Okay. So, when some charge is transferred to a conductor, it readily gets disturbed over the entire surface of the conductor. So, the purpose of sharing the charge with the earth is called as grounding or earthing, will say. Like usually we have seen these kind of diagrams, right. So, this diagram usually represent the grounding or it is earthing, we will say. Like the extra charge whichever we are getting from the source of outside, like transformers, no, that one will be going through this grounding or the earthing process. The process of sharing the charges, okay, that is called as grounding. So, earthing provides a safety measure for electrical circuits and appliances. Like the thing is, when we get the extra charge particles are there, like extra electricity, no, like those kind of things will be transferred through this circuit, that is called as grounding or earthing, will say. Okay, in this kind of things, like we can get the safety purposes, right. So, substance which offers high resistance means like there is no passage of the charge particles or current. Charge are called as insulator. Example, non-metal, glass, proclines, plastics, nylon, woods. So, if some charge is put on an insulator, it stays in the same place, but for the conductor it keeps on moving, right. That is the thing they have told, like it is getting disturbed frequently over the time period. So, basic properties of charges. So, these are the important things when we come across in the theory part of the questions in EAPCET. So, charges as magnitude but no direction. So, like when we talk about the thing, no, two wires are there, for example, which has been like called as A wire and B wire, and the resultant wire is C we will take. Suppose if I talk about the current is coming from A wire is 2 ampere, current coming from B wire is 1 ampere, what will be the current in the C wire? Like I am getting like current from A and B, which is called as 2 ampere and 1 ampere, the resultant will be obviously the 3 ampere. I can't take the vector addition or subtraction kind of things, right, no, in these things. So, like if we talk here, like it is a scalar property. So, no direction, which is similar to mass. So, mass of a body is always positive. So, charge can be positive or negative, right, no. So, mass of a body is always negative, so positive we have said, no, like this property which we have seen in class 11th, that is gravitation. So, when we compare this gravitation and the electrostatic chapter, like it will be easy to understand. So, we will go for the formula point of view also. In that formula we would have saw in the gravitation, that is G m1 m2 by r square, right. Now, here also the similar kind of formula only, F is equals to K q1 q2 by r square, right. Now, so when we are seeing this formula, it is almost similar, na, right. So, that is the thing we are going to talk here. And charge adds up like a real number. So if a system contains n charges q1, q2, q3 up to q1, like the total number of charge will be q1 plus q2 plus q3 up to qn. Okay. So the total, like if for example if we are having plus 1 plus 2 plus 4 minus 3 and minus 5 charges, what is the sum of charge in the system? So 1 plus 2, that is 3, 3 plus 4, how much? 7, 7 minus 5 minus 7, 2, and 2 minus 3 is minus 1. So minus 1 is the answer for this system, right? No. So plus 1 plus 2 minus 3 plus 4 minus 1 minus 5. So which gives the minus 1. So if the size of the charged bodies are very small as compared to the distance between them, we treat them as a point charge. Okay. So these are the basic idea and the basic properties about the electric charges, right? You can take a note of this and we can go for the next one. Done? Yeah. So next important property is charge is conserved in nature. So conserved in nature. So this is one of the important property. Charge can neither be created nor be destroyed. It can be transferred from one object to the other object. So this sentence we have studied in the work, energy and power also. Right now energy, like energy can neither be created nor be destroyed, it can be transferred from one to other system we have told. So charge is an isolated system, always remains constant, Sometimes nature creates charged particle and neutron turns into proton and an electron. So for example if we take any system, okay, any system. Now what is the thing I am doing is I am taking plus 6 minus 2 and plus 7. So one more charge we will take minus 4. Okay, these are the charges I have taken in this system. So what is the sum of the charge present in the system? So 6 plus 7, 13, 13 minus 6, again it is 7, right? No, it is equals to 7. Which 7? Like plus 7 we should write that, like the symbol also important, okay? And when I talk about the same thing, like I have shake something, like I have displaced the charge, displaced in the sense like I am shaking the system and the charge now is like minus 5, minus 7 and plus 1. Okay, this is the charge. Okay, so one more charge will be there, like x. Let me take for example x I will take. So what is the charge of the x? What is the charge of the x now? So when we talk here minus 5, minus 7 plus 1 plus x will be equal to how much? This 7. The total charge which is present in the system is 7. Now if I see minus 7, no, so minus 7 minus 5, if it goes this side it will be plus 12. So x will be equals to 7 plus 12 minus 1. So 7 plus 12, which is nothing but 19, 19 minus 1 is 18. So the value of x is nothing but 18 now. Okay, so this is the important property, like which we have seen in the properties of the electric charge. So charge is always conserved in the nature. So the proton and the electron thus created have an equal and opposite charge, right? So if I talk about Q which is positive, Q is negative. If I take Q plus Q as 1, minus Q will be, obviously it will be minus 1, right? It will be minus 1. That is the thing we have told, like equal and opposite charge, okay, proton and the electron. The values which is nothing but it is Shahid. Yes, it's MZ class. Okay, yeah, it's MZ class only. So next one, quantization of the charge. So quantization is nothing but when we talk about charge, no, it is the integral multiple. When we talk about E value, like the value of the electron, it is nothing but 1.6 into 10 power minus 19, right? No, right. So when we talk about this electron, I will say it's a 1 electron, 2 electron, 3 electron, or else a minus 1 electron, minus 2 electron, like this, na? Like this we will tell. I can't say that it has 1.2 electron or 1.4 electron like this. Like, is it possible 1.2 into 1.6 into 10 power minus 19? No. When I talk about this one, 2 into 2 times of the minus E, right? No, 2 times of minus E, which is nothing but 1.6, sorry, 2 into 1.6 into 10 power minus 19, right? So 2 times, 3 times, or minus 1 time, minus 2 times. We can't take the decimal value, like it is an integral multiple. The meaning of integral is nothing but like we should take without the decimal values, right? So all free charges are integral multiple of the basic unit charge, that is E. So the value is nothing but 1.6 into 10 power minus 19, right? So Q will be equals to plus or minus Ne, where N is the integer, it is integer. So integer like 0 plus 1 plus 2, like 0, 1, 2, 3 up to infinity, here minus 1, minus 2 up to minus infinity, okay. So the basic unit of charge is the charge of that electron or proton carries. So the charge on electron is taken as be negative and the charge of proton is taken to be plus, that is plus E, positive, okay. So the SI unit of the charge is coulomb. SI unit of charge is coulomb, okay. We will see a question based on this. We will see a question based on this. Done, taken down, okay. So 1 coulomb is the charge flowing through the wire in 1 second of the current of 1 ampere, right. So it is nothing but 1.602192 and it going, okay, into 10 power minus 19. So approximately we will take 1.6 into 10 power minus 19 coulomb, okay. So there are about 6 into 10 power 18 electrons in charge of minus 1 coulomb. So how they have calculated this? How they have calculated? 1 coulomb will be equals to 1.6 into 10 power minus 19, na? So when I talk about 1 divided by 1.6 into 10 power minus 19, right? No. So we are talking about the value of this, that is nothing but 6 into 10 power 18 electrons, okay. So 1 microcoulomb is nothing but 10 power minus 6 coulomb, and 1 millicoulomb is nothing but 10 power minus 3 coulomb. Okay. So, if the proton and the electron are the only basic charge in the universe, this is the basic thing. Proton is positive, electron is negative. When we talk about the zero charge, which is nothing but it's a neutron. Okay, so no charge will be there. So, if a body contains N1 electron and N2 protons, so total amount of charge of a body is N2 times E and N1 times minus E. So, N1 electron we have told, no, N1 into minus E and N2 into plus E, and I will sum up this two things. I will get the value of the total amount of the charge in a body. So, N1 and N2 are integer, their difference is also an integer only. For example, if I take this is 5 and this is 7, so I will get minus 2. So, minus 2 is an integer, okay, minus 2 is an integer, right. So, minus 2e, which is nothing but 2 into 10 power 1.6 into 10 power minus 19, that is the value, 2 times of minus e. So, here is the question. If 10 power 9 electron moves out of a body to another body every second, how much time it required to get a total charge of 1 coulomb on other body? So, this is the question. 10 power 9 electrons. Okay. So, it's moving to other body, like keeps on moving to other body in every 1 second. So, how much time it will take? How much time it will take for a charge of 1 coulomb on other body? Okay. So, you have a solid 2 minutes time for this question, right? You can start doing now. So, whoever watching, you can give answer in the comment section, or we will check the answers once you have completed. So, last 1 minute. Done? Okay, we will see the answers now. So, it is 198 years. Whoever given the value as 198, that is the correct answer. So, we will see how. So, in 1 second the electron is going is nothing but 10 power 9 electron, right? No. So, when we talk about 1.6 into 10 power minus 19 into like 10 power 9 coulomb charge takes time in moving out is 1 second, like electron to 10 power 9 in electrons, which is nothing but 10 power 9 into 1.6 into 10 power minus 19. So which gives the value 1.6 into 10 power 9, sorry 10 power 10, right? Yeah, 10 power 10, right? So minus 10 it is, not 10, it is minus 10. So 1 coulomb, like we are talking about 1 divided by 1.6 into 10 power minus 10. So it is nothing but 1.6 into 10 power 10. Okay. So now if I divide this thing, no, I'll get the value. That's it. 1 by 1.6 into 10 power 10. So we need in years. That's it. That is 198 years. Okay. So next is a Coulomb charge. A force of attraction or repulsion between two stationary electric charges directly proportional to the product of magnitude of the two charges, and inversely proportional to, like, product of magnitude of two charges. So when I talk about Q1 charge and Q2 charge, okay, whatever the force is exerted by Q1 on Q2 or Q2 on Q1 will be always equal. Okay, and if I increase the distance, for example, if I talk about a magnet, north pole is there and here it is the south pole, or again one more north pole I will take. Okay, when I bring together, both magnet will exert equal amount of force and in the opposite direction, right? Now because north and north repel each other, right? So in opposite direction, but if I keep far away, the force will be decreased, right? So and inversely proportional to the square of the distance. So I can say F is directly proportional to Q1 Q2 and F is inversely proportional to R square. So when the distance is increased, force will decrease, or when the distance is decreased, force will increase. So remember this point, when the distance between the charge particle increases, force will be decreased. When the distance between the charge particle decreases, force will be increased, right? So when we add both the things, we will get Q1 Q2 by R square. To remove the proportionality, we are adding a constant called K, which is nothing but the Coulomb's constant. And the value of K is nothing but K is equals to 1 by 4 pi epsilon naught. That's the value. So in numerical it is 9 into 10 power 9 Newton meter square per Coulomb square. Okay, and epsilon naught is the permittivity of the free space. How much the flow of the electron has been taken in the space, okay, or in any material. So this epsilon naught will be varied, depends upon the material. It is depends on the material. Okay, so the epsilon naught value is nothing but 8.85 into 10 power minus 12. Okay, so you should remember these values of both the things, K and epsilon naught. Done. okay, and we'll see now electric field. So for this I'll explain a thing, electric field, in a simple way. When we take so when we take a space, okay, so in this a field is present, electric field, which is denoted by the E, letter E. So how we can observe this, how we can analyze this electric field? For example, if I take a positive Q, which is a test charge, we'll say test charge. So if I keep a test charge here, simply it doesn't experience any kind of force, but if I take this positive charge inside this space, no, it will experience as a force. For example, no, a person is standing and simply swinging his hand, other person is standing here and silently is watching this person, he is swinging his hand, okay. Now this person is going near and near, okay. Finally I have reached near to the person. Now the person is swinging his hand, no, obviously what will happen? He will experience the force of the person's hand, right. So that's the example we can take here and we can analyze in this. So if I keep a charge somewhere, it doesn't experience any kind of force, but if I take this charge to the field, it experiences a force. So I can say that E is equals to F by Q. I am placing the charge like test charge in the field and experiencing the force. So what is the value of F we have talked? F is nothing but 1 by 4 pi or K Q by R square, right? No, K Q by R square. So if I substitute the value here, E is equals to K Q by R square divided by Q. What happens? Q and Q will get cancelled off. So the remaining term will be KQ by R square. So this is the value of the electric field. This is the formula for the electric field, right? So you can take a note of this. Done? Okay. Now you can see this. So the electric field due to a charge Q at a point in a space may be defined as the force that unit positive charge would experience if placed at a point. So this positive charge will experience a force. Where it will experience a force? Wherever the electric fields are there, it will experience a force. Okay. So the electric field produced by the charge Q is nothing but E is equals to 1 by 4 pi epsilon naught Q by R square, right now. So we have written the formula, E is equals to K Q by R square. So what is the value of K? 1 by 4 pi epsilon naught Q by R square. So the force exerted by the charge Q on a charge Q, like capital Q and the small q, is placed at a point as Q into Q by R square, right now. So usually we will say this F is equals to QE or E is equals to F by Q. So what is the like SI unit? Like force it is Newton and charge it is Coulomb. So Newton Coulomb is the SI unit of the electric field, right? Done? Okay. So the charge Q which is producing the electric field is called source of the charge, and charge small q which tests the effect of the source is called as test charge, we will say, right. So if the source charge is positive, the electric field will be directed radially outward. If it is negative, it will be inward. So positive means it is radially outward, if it is negative means it is radially inward. Okay. So the symbol, so positive and the negative, the source of the charges. Okay. And when we consider two charges, positive and negative, how it will be looking like? So positive to negative. So positive it is going out and negative it is coming in. Okay. Done? Okay. So since Q is positive, no, the force and the electric field are in the same direction. If Q is negative, the force and the electric field will be in the opposite direction. So the question will be like, when we place a positive charge and the electric field in, like, how the direction will be? So it will be parallel. So this is anti-parallel. Parallel, anti-parallel. Wait 1 minute. Okay. So this is for positive Q and E, and this for negative Q and E, right. So this is the directions of the positive Q and E, negative direction of, direction of negative Q and E. So electric fields and lines, like the properties. So when we talk about a property, it's an imaginary line that shows the path of the positive charge in an electric field, and field line starts from the positive charge and end in the negative charge. So tangent drawn at any instant of the field line gives the direction of the electric field. So two field line can never intersect each other. If it intersect, no, like direction will be two, like it has only one direction. It doesn't possible, like it, as electric field cannot have two different direction at a point, it is not possible. So electrostatic field line do not form any closed loop. Okay, these are the properties of the electric field lines. And the number of field lines cutting the area element proportional to the magnitude of the field at this point. Okay, and electrostatic field is conservative in nature. So yeah, when we talk about the thing, no, the area. So when I see this point and this point, okay, if I talk about this point and this point, no, this, in this point the number of field lines are cutting more, because like it is near to the charge. When we are going away from the charge, the number of field lines will be cutting, will be decreased. Okay, the passing of the field line will be decreased. When we are near to the point charge, the force also increased, right? So and the field also increases, the field lines also increased. So the next topic is electric flux. So electric flux is nothing but, so if I talk about okay, let me take electric field lines, and I am taking any surface here, any surface. So the passing of the field lines through any surface, okay, like through the surface is called as the flux. The amount of passing of the electric field lines through the surface area is called as the electric flux. And when we talk about the angle is important here, okay, if I tilt this, like number of passing of the field line will be decreased. So if you see here, the total number of electric field line crossing per unit area is called as electric flux, and which is denoted by the letter phi. Okay, the product of area and the component of the electric field, which is normal to the area. So E cos theta dot, like, okay, we will see this formula E dot ds. So when we talk about the dot product gives the cos theta, right now. So Ed cos theta, So electric flux depends upon electric field lines, area and the angle. So these three things are important when we talk about the electric flux, and the SI unit is Newton meter square per coulomb, and it is a scalar property. Okay, this is about the electric flux. So with this I will stop for today's topic, and we will continue the next topic in the upcoming classes. So thank you guys, we will meet in the next class. Bye bye.